Hello everybody, Earth.Otherwise here to continue our journey into game programming in C++, start to finish by Eric Yuzwa. In this, the first part of the fourth chapter of the book seeks to teach us about game engines and their uses. Game engines typically handle graphics for the most part, though often they will include things for input, sound, networking, AI, and more depending on how robust the features of the game engine are. Most commercial games are built atop a game engine. Some famous game engines include Unreal, Frostbite, and Unity. When making one's own game engine, we must consider how specific, general, and robust we wish to make it. If we go too far in any of those directions, we'll end up wasting our time, so it's something we should consider carefully. Ideally, your game engine is modular enough and robust enough that you can apply it to most projects with minor tweaks, but there will no doubt come a time when your engine simply isn't correct for the job and you will have to use another. You must always consider what's best for your game. In fact, if you simply want to make a game right off the bat, then choosing to design and code your own engine like we're doing now would be the absolute wrong choice. Fortunately for us, we aren't interested in the quick route to success. Instead, we'll have complete control over our engine's limitations. Throughout this book, we'll be adding to our engine. Indeed, as long as you are using a custom engine, you will probably continue adding and modifying it to suit your needs. The engine that GPI C++ seeks to help us create will be relatively lightweight, and hopefully will be easily modified for the kinds of games we'll want to make once we understand fully how to do so. Now, let's go over the parts of the engine that we'll be seeing later in this book. The engine core is what this book calls what we did in the last chapter. In the instance of this book, I believe that the input, window, and error handlers were all in a single .cpp file. Clearly, we did not do this, since code modularity is important. The engine core is responsible for launching the game, opening a window, starting up SDL, and sending us into the main game loop where we will handle our inputs. It's also responsible for loading our other engine parts. Obviously, our classes don't currently do this, but later on we'll probably use the .h file that shares our engine's name to act as our main loop which our game will call. Next up is our audio engine, which, as you can guess from the name, will be handling our audio. Now, just as with our engine core, we'll probably have several files with several classes which will make up our audio engine, but this book treats them all as a single object. This book uses the audio mixer in SDL, which I have heard works fairly well. I'll also be inserting the audio information from Ben, of course. OpenAL is also used, the audio equivalent to OpenGL. This is all covered in Chapter 11. Script engine is next. It's a small component of our overall engine, which will take in scripts when we launch the game and during runtime. Scripts, for those who don't know, are essentially simplified code snippets that you can use to program parts of your game without having to recompile the entire thing. An example of scripting that we've already done is our init file read-write class. GPI C++ uses Lua L-U-A, scripting library, which will be covered in Chapter 19. Scene Renderer is another core component of the Peon engine that the book uses. It is the interface between the game and OpenGL. The book talks about this in Chapter 6. Scene Texture is a container for texture information and is used by the Scene Renderer to put textures on screen. Scene Font is the same as Scene Texture, but for words and letters. Scene Graph Manager, which we'll find in Chapter 8, is a class or group of classes responsible for speeding up our calls to the scene renderer so that drawing to the screen is quicker and more efficient than calling everything one at a time. It will also aid in physics and collision detection. Network engine is the multiplayer aspect of our game engine and something I'm sure we're all curious about. Everybody wants to make the next multiplayer smash hit. We'll learn about this in chapters 14 and 15. Particle emitter is a simple particle generator for things like explosions and fire. Shockwave is a fun little subsystem that will give us a little effect that we can apply in-game. And those are the basic parts of our game engine. When each part is activated in the main game loop, it will be put into an active state. Different parts of our game will be part of different states. For example, we will have a state that tells the game we're in the main menu, or that the player is active, or that the player is dead, or perhaps that we're in the system menu. This is how the game will know to switch into different loops within the core loop. Now, as any Google search can tell you, state machines can get big and cumbersome. So what the Peon engine and what our engine will do to combat this is use an application and application state class to keep things orderly. How it's going to do this is as much a mystery to me as it is to you. Let's keep going. Now we move into the realm of time boxes, defined by this book as a defined goal with defined resources, including time. Now, we aren't going to define how much time it's going to take since we're all busy people, but we should draft the list of requirements for basic functionality. Fortunately, the book gives us an example. These are the requirements for the next time box. 1. Initialize and start up the application. And 2. Create some state container that we will fill as development progresses. Well, that seems pretty easy with only 2 things, and we've already done one of them. In order to figure out what we'll need in our state manager, we'll need to think of the states the game can be in. The book provides some examples of what these states can be. There can be a logo state, which is a pop-up for a company logo and maybe playing a little jingle that you see often at the beginning of games. A main menu state, which will load in and display our main menu, as well as provide the functionality required of a main menu, including the ability to change settings, aka our initialization file. A run state, which is basically just running the game, and will be broken into multiple substates. And a quit game state, which will clean up everything in our game and close it down. This will also probably check to make sure that the game is saved. Now that we have an idea of what we want, it's time to move on to the next video and create our UML diagram.